Welcome to The Explainer. Every time you make an API call to a large language model, you're paying per token. But have you ever stopped to think about what you're really paying for? Today, we're going to follow the money, all the way down to the silicon, to uncover the hidden economics of AI inference. And we'll see how it's shaping the entire industry.
So here's the plan. We'll start by breaking down the fundamental constraints that make this whole thing so expensive. Then, we'll dive into the key innovation that's taming those costs. It's all about something called the KV cache. From there, we'll check out the competitive world of inference engines, see how the big cloud companies package it all up, and wrap up with the strategic choices you need to be thinking about.
All right, let's get right to it. That per token price you see on the billing page, it's not arbitrary. It's the result of every single provider fighting against two incredibly difficult technical constraints. So what does it really cost to generate one of those tokens? It sounds like a simple question, right? But the answer is actually buried inside the super complex optimization problem. And it all comes down to two major hurdles that every LLM serving system is constantly battling.
See, every serving system is in this constant tug-of-war between speed and capacity. On one side, you've got the latency problem. Tokens get generated one by one by one. It's just inherently slow. But on the other side, you have the throughput problem. To generate tokens at all, the model needs this kind of computational scratch pad. It's called the KV cache. Think of it as the model's short-term memory. The longer your conversation, the bigger this scratch pad gets, and it just eats up enormous amounts of super expensive GPU RAM. That's what limits how many people can use the service at the same time.
So, that KV cache, it's pretty much the main character in our story today. Because solving the memory bottleneck it creates is the single most important challenge in making AI inference affordable. And you won't believe how inefficient the standard way of handling it is.
That's right, research from the team behind a project called vLLM shows that typical systems can waste between 60 to 80% of their GPU memory. Now, this isn't a problem with the hardware, it's a software problem. It's all about fragmentation and reserving way too much space, kind of like booking an entire banquet hall for a dinner party of 4. Just pure waste. So how do you fix this? Well, the solution, first brought to light by the open source engine vLLM, is this brilliant innovation called paged attention, and it completely changes the game. Instead of trying to find one gigantic continuous block of memory for that KV cache, it treats the GPU memory just like your computer's operating system treats RAM. It breaks it up into smaller, non-contiguous pages. The simple but powerful idea slashes the waste and lets you pack way more requests onto the exact same GPU.
And to really get why this is so critical, you have to know that inference isn't just one step. It actually happens in two distinct stages. First, you've got the prefill step. This is where the model just gobbles up your entire prompt all at once. It's heavy on compute, and it's parallelizable. But then comes the second step, the decode stage. This is where it generates your answer one token at a time. This part is heavy on memory, and it's sequential. So by optimizing the KV cache, you're directly attacking the bottleneck in that second, much slower stage.
Okay, so once everyone figured out that efficiency was the name of the game, it kicked off this fierce competition. It's led to a whole wave of specialized open-source inference engines, and they're all competing to squeeze every last drop of performance out of every single chip.
And here are the main players on the field. You've got Hugging Face's TGI, which is a really solid production-ready server. Then there's vLLM, laser-focused on that memory efficiency with paged attention. Of course, NVIDIA has its own, TensorRT-LLM, which uses these hyper-optimized software kernels to get peak performance on their own hardware. And you're even seeing newer players like SGLang, designed specifically for really complex multi-step agent workflows.
And the performance stakes here? They're absolutely massive. An engine like vLLM can get you up to 24 times higher throughput compared to a basic setup. And when you're paying for every single token, a 24x improvement isn't just a nerdy technical detail, it fundamentally changes your business's unit economics.
Okay, so that's what's happening in the open source world, but what about the big guys? AWS, Google, Azure. How are they taking all this super complex optimization stuff and packaging it into those simple per-token APIs that we all use every day?
Well, it turns out they've all kind of landed on three main ways to sell you their GPU power. First, there's on-demand. That's your standard pay-as-you-go model. Super flexible. Then you have provisioned, where you reserve a chunk of capacity for a fixed cost, which is great if your traffic is predictable. And finally, there's batch mode, which is deeply discounted for any job that doesn't need an answer right this second.
And this right here is the simple genius behind batch mode. Providers like OpenAI, Azure, and AWS are basically saying, hey, if you can wait, we'll give you a 50% discount. And why would they do that? Because it lets them monetize their idle capacity. They can run your job whenever their expensive GPUs would otherwise just be sitting there doing nothing. It's a total win-win for hardware utilization.
The other huge trick up their sleeves is something called prompt caching. Remember that pre-fill step we talked about where the model processes your input? Well, prompt caching just stores the result, that KV cache, for common prompts. So if you send the same opening prompt again, the system can skip that whole expensive pre-fill step. It's a shortcut that saves both time and money. And the impact of this can be just incredible. For apps that have a lot of repetitive inputs, like a customer service bot that always starts with the same system prompt, this is a total game changer. Google claims this can slash your input token costs by up to 90%. That is a massive lever for anyone building with structured, repeatable prompts. So, after looking at the constraints, the engines, and the cloud products, what does this all mean for you? Well, it really all boils down to that classic tech decision. Do you build or do you buy?
You've really got two main paths. On one side, you can use a turnkey API from a provider like OpenAI or Bedrock. It's super reliable, has low operational hassle, but you pay a premium for every single token. On the other hand, you can roll up your sleeves and self-host an open-source engine like vLLM. This gives you the best possible cost efficiency and total flexibility, but it comes with a ton of operational work and you need some serious expertise.
Ultimately, understanding this whole inference economy isn't just a technical detail anymore. It's a core strategic decision. You have to ask yourself, where does our real competitive advantage come from? Is it in the model itself? Is it our unique data? Or is it simply having the most ruthlessly efficient serving stack on the planet? The answer is going to define your costs, your ability to scale, and really your future in this new ecosystem.